Welcome to Study Loop.
Our question says that an athlete executing a long jump leaves the ground at a 27-degree angle and lands 7.8 meters away. Then it asks A, what is the takeoff speed? And B, if the speed were increased by just 5%, how much longer would that jump be? So I wrote down what we were given here. We were given that the takeoff angle, theta naught, is 27 degrees, and the distance that he jumps, or the range, is 7.8 meters. And we want to find V naught for part A, which is the takeoff velocity. Well, to do that, we can use the range formula. Range is equal to V naught squared, V naught being what we're trying to find here, times the sine of 2 times theta naught, divided by g, which is the gravitational acceleration here on Earth. Now, if you solve this for V naught, you get the square root, because V naught is squared, of r times g, because we move g to the other side of the equation by multiplying both sides by g, divided by sine 2 theta. So we're isolating V naught. Okay, and if you plug in all the values we have here, well, the range is 7.8 meters. Gravity, 9.80 meters per second squared, because it's acceleration. Extend the square root because this is all under the square root. And this is all divided by sine 2 theta. Well, 2 theta is 2 times 27 degrees, which is 54 degrees. So this is sine of 54 degrees. Okay, you plug all that into the calculator and you find that V naught is equal to 9.72 meters per second, because it's velocity. Okay, box that in as our solution to part A. Now part B says, what if we increase that velocity? Right, open up a new window for part B. Part B says, what if we increase that velocity by just 5%? It wants us to calculate the new range value from that increase. So we're going to call this new velocity, initial velocity V naught prime, and it's 5% more than the old velocity. So 5% of the old velocity, well, percent is a ratio relative to 100%. So we have to convert that into this fraction. So 5% divided by 100% times the initial velocity, okay? And it's a 5% increase from the initial velocity. So we're adding that 5% of the initial velocity to the initial velocity, which is just 0.05 V naught plus V naught. Well, if you plug in V naught, which we found on the previous page to be 9.72 meters per second in, you find that this is equal to 10.2 meters per second. Okay, now that we have that, we can calculate the new range value, which I call r prime, which is going to be equal to V naught prime squared sine 2 theta naught divided by gravity. So if you plug in all the values that we have, V naught prime squared, so you'd be 10.2 meters per second squared, times the sine of 57 degrees divided by 9.8 meters per second squared, you find that this comes out to 8.59 meters. But the question asks, how much further is the new value than the old value for the range? So we need to take r is equal to r prime minus the old range, which is equal to 8.59 minus the old range, which was 7.80. And you find that this comes out to be 0.79 meters, and that's longer. Box that in as our solution to part B.